Hey guys, welcome back to this week's video. This week we are going to discuss on quiz chapter 6 chemical kinetics. So let's begin with the first question. Consider the reaction A plus B will produce C, and given to you are the 3 experiments. So for each experiment, the concentration of A and B and the rate are given to you, and you were asked to determine the rate law expression for this reaction. So when you want to know the rate law, you should write a rate law equation first. So rate is equivalent to K, concentration of your reactant. So in this case, you have 2 reactants, A and B. So reactant A to the power of X times reactant B to the power of Y. So from here, you will need to calculate the value of X and the value of Y. So how are you going to do so is by using the table given to you. So from the table, if you were to calculate the value of X, you need to find the concentration of B that is similar. On the other hand, when you want to find the value of Y, you need to find the concentration of A that is similar, which will be easier for you to calculate. So in this case, I'm going to start with finding the value of Y. So I need to find the value of concentration of A that is similar. So I will use experiment 1 and experiment 2. So 4.0 times 10 to the power of negative 5 divided by 4.0 times 10 to the power of negative 5 is equivalent to K. So for experiment 2, the concentration of A is 0.1 to the power of X, and the concentration of B is 0.2 to the power of Y. So moving on to experiment 1, so both are 0.1. Okay, 0.1 X, 0.1 Y. So from here, since these are the same, so you can slash things out, and these are the same, you can slash this out as well. So 4 divided by 4 equivalent to 1. So you should get 2 to the power of Y. So how are you going to find Y? So you need to bring the Y to the front. So you need to put ln. So Y ln 2 is equivalent to ln 1. Therefore, Y is equal to 0. Same goes with when you want to find the value of X. So when you want to find the value of X, you need to find the concentration of B that is similar. So in this case, we are going to use experiment 1 and experiment 2. So same goes, rate equivalent to K, concentration of A to the power of X, and concentration of B to the power of Y. So now, we are going to use experiment 1 and 3. So it's easier for us to calculate like experiment 3 divided by experiment 1. So rate is equivalent to 16.0 times 10 to the power of negative 5 divided by 4.0 times 10 to the power of negative 5 is equivalent to K, 0.2 to the power of X, and 0.1 to the power of Y. So the other one will be 0.1 to the power of X and 0.1 to the power of Y. So same drill. This one is the same. This one is the same as well. So from here you will get 4 equivalent to 2 to the power of X. So what you need to do is bring this X to the front. So X ln 2 equivalent to ln 4. So you get X equivalent to 2. Therefore, when you want to find the rate, so you just copy back. From the calculation before, we get the value of y is equivalent to 0. So y equivalent to 0 and x is equivalent to 2. So you copy back again. So rate is equivalent to k a to the power of 2 and b to the power of 0. Or you can say that rate is equivalent to k a squared. So this is your final answer for the first question. Moving on to the second question. So for the second question, consider the reaction such. The reaction is following the second order reaction with a rate constant of 5.76 times 10 to the power of negative 2 under certain condition. If the initial concentration is 0.2, determine the concentration after 10 minutes. So, in this case, what you need to check upon is the unit. So, given to you, the rate constant is in mole per minute, liter mole per minute. So, this one and this one, you check. This one is in mole, that's 5, and the time is in minutes. So you don't have to convert the time into second because the rate constant is already in minutes. So you need to use the second order reaction. So for second order reaction, the formula is 1 over AT is equivalent to KT plus 1 over A naught. So you were asked to calculate what is the final concentration. You are asked to calculate your AT. So what is your AT? So 1 over AT equivalent to K. What is your K? Given to you in the question, the rate constant. So equivalent to 5.76 times 10 to the power of negative 2. And your time, given also in the question, 10 minutes. 10. So this plus 1 over A naught. What is the concentration of the A naught? So see, if the initial concentration is 0.2, so your A naught is 0.2. So after you have done this calculation, you should get 1 over AT is equivalent to 5.576. So you should get the value of AT equivalent to 0.1793. So this is the answer for the second question. Question number 3. Consider the following chemical reaction. If the rate of disappearance of oxygen is 0.065 per second, infer the rate of disappearance of Fe or the ferrum and the rate of formation of iron trioxide. So, when you get this kind of question, the first thing you need to do is you need to write the rate expression. So remember, when you want to write the rate expression, whatever in the reactant should have negative sign and whatever in the product should have positive sign. So you can say that the rate expression for this is equivalent to negative 1 over 4 delta concentration of Fe delta T equivalent negative 1 over 3 delta concentration of O2 delta T equivalent to positive 1 over 2 delta concentration of Fe2O3 over delta T. So from here, we need to look back at the question. The question states here that the rate of disappearance of oxygen is equivalent to 0.065. So in saying that, we can say this part, disappearance of oxygen, is equivalent to 0.065 per second. Alright, so what we can do is that when we want to find the ferrum, for example, so for the ferrum, we are going to look at this part of the equation. So negative 1 over 4 is equivalent to negative 1 over 4 delta Fe over delta T is equivalent to negative 1 over 3 times 0.065. Alright, so it's easier for you to like calculate this one first. Then you can get delta Fe delta T is equivalent to this one. You need to put up here, so you will get 0.0217 times 4. So you should get 0.0867 per second. So since the ferrum is at the reactant, so you need to have negative over here. Although if you can see here, you can slash them out, but we need to check on the position of the element. So since ferrum is at the reactant, so it should have negative sign over here. So we are going to look for the ways to calculate Fe2O3. So from here we can say that from the rate expression, negative 1 over 3 delta concentration of oxygen delta T is equivalent to positive 1 over 2 concentration of Fe2O3 delta T. So given to you is the value of oxygen, right? The disappearance of oxygen. So same goes, negative 1 over 3 times 0.065 is equivalent to 1 over 2 delta Fe2O3 delta T. Right. So from here, you can say that this one you need to calculate, and then this one you bring up. So you should get 0.0217 times 2 equivalent to delta Fe2O3 delta T. So you should get equivalent to 0.0434 per second. So since this is at the product, so it should have positive sign over here. So this is your final answer for this question.